Welcome back to Math 104. Two fair six-sided dice are rolled, and we consider the event f that the sum of the numbers is at least 9. We have a diagram that illustrates which outcomes belong to the event f, and all the blank spaces in the grid correspond to outcomes that do not belong to f, in other words, that belong to f complement. We see that there are 10 ways for f to occur, and that means that there are 26 ways for f complement to occur. So for every 10 times that f happens, there are 26 times that the opposite of f happens. In other words, the sum of the numbers is less than 9. Now you might be tempted to write the odds in favor of f, therefore, as 10 to 26, ways that f can happen compared to ways that not f can happen. But there is a tradition that we write this ratio in simplest terms. In other words, 10 and 26 have a common factor of 2, and after we cancel that out, we find that a ratio of 5 to 13 is in the same proportions as 10 to 26, so we write the odds as 5 to 13 in favor, which means 13 to 5 against. The fact that the larger number appears first, when we're talking about odds against, means that f is more likely not to occur than to occur. If you wrote the odds in favor of f as 10 to 26, you're not a bad person, but to do this completely correctly, you really should write 5 to 13 instead. In general, how can you go from the probability of an event to the odds in favor of the event? So if you have the probability of an event E, if that's a known quantity, then to find the odds in favor of E, you want to compute probability of E divided by the probability of E complement. Right? If you know the probability of E, then 1 minus that is the probability of E complement. You want to compute this fraction and express it in simplest form as a over b, where a and b are integers you get from simplifying here, such that there is no interesting common factor between them. They have no common factor greater than 1. Think of it this way. If you compute this probability of E divided by the probability of E complement, and you obtain this fraction A over B, then, for every A ways for the event E to occur, there are B ways for E not to occur. Once you've done all this and obtained this fraction A over B, then we say that the odds in favor of E are A to B. Okay, that's how we read it, A to B. Let's work out an example. If it is given information that the probability of E equals 0.8, we ask, what are the odds in favor of E? Well, we compute probability of E divided by probability of not E. We want to know the ratio of the likelihood that E does occur to the likelihood that E does not occur. Where did this 0.2 come from? It's 1 minus 0.8. So we simplify a bit. This is 8 over 2. Let's first turn these into whole numbers. Given a fraction with decimals in it, I'm allowed to move the decimal point one place over in both the numerator and the denominator, and the result will still be equal to what I started with. So I move the decimal point over. I have 8 over 2, but that's not quite in simplest form. We need to say that that's equal to 4 over 1. Therefore, the odds in favor are 4 to 1. That means, in turn, that the odds against are 1 to 4. We simply reverse these numbers. In this example, probability of E is what's already known, and the question mark is, what are the odds? What about in the other direction? If we know the odds, how do we find the probability? Let's suppose that the odds are A to B in favor of the event E occurring, which means that we can draw a strip diagram which has A boxes marked by E, followed by B boxes marked by E complement. And just to make this line up with our previous example, I'm going to draw it like so. Here the odds were 4 to 1 in favor of E. Given that the odds are A to B in favor of E occurring, that means it's true that for every A ways for the event E to occur, there are B ways for E not to occur. That means that there are A plus B total ways for something to occur. Thus, there is an A out of A plus B probability that E occurs, right? The fraction of the time that E occurs is A out of A plus B. And similarly, there is a b out of a plus b probability that e complement occurs. The fraction of the time e complement occurs is this number b divided by a plus b, the total number of boxes. This thinking, this approach, enables us to go from odds back to probabilities. Thus, whichever one of these two we know, we can figure out the other. Now here's a word of caution. Don't just rely on memorizing formulas. Instead, think in terms of what odds and probabilities mean. I've often seen students try to pull formulas out of a hat, and they have ended up misusing them. In particular, think in terms of ideal datasets represented by strip diagrams. You'll understand better, and you will make fewer mistakes. Let's try this out, converting from odds to probabilities. If the odds that Rutgers will play in a postseason game are 5-2 in favor, then what is the probability that Rutgers will play in a postseason game? Let's go to the strip diagram. 5-2 odds in favor means that we're going to mark off 5 boxes with, say, the letter R, and the other 2 boxes with not R. That means that there are 7 boxes total, so the probability we're looking for is 5 out of 5 plus 2, which is 5 out of 7. We could go and try and look up that formula from before about A over A plus B, but we are much likelier to get it right if we just stop and think what's really going on and represent it by a strip diagram. Before going on to the next video, answer the following questions. If the odds that Rutgers wins its next game against Michigan are 5-1 against, then what is the probability that Rutgers will win? And someone offers you the following bet. If Rutgers wins, you receive $10, and if Rutgers loses, you pay $3. Is this a good bet from your point of view? Now, we haven't exactly done a problem like this yet, but here's a hint. You know everything you need to know to solve this. Think in terms of the actual amount of money you would make or lose over the course of an ideal data set of games. Think what's an ideal data set of games between Rutgers and Michigan, and whether you'd overall make or lose money.